scale y, and the y lower point of the y where the water freezes is equal to 160 minus में highest point means when the water boils is at the minus 50 degree y, and we want to convert the 340 Kelvin into this y scale. Then we know the 340 and Kelvin lower point is at the 273. Total number of divisions are 100. On the y scale it is a y minus of minus plus 160, and the total number of divisions are 110. So it is a 340 minus 270, 340 minus 273, 67, that is multiplied by 11 is equal to y plus 160, and that is a 73.7, and equal to y 1 plus 60, it means minus 160. So the temperature on this y scale is a minus of 86.3. So correct option is a third one. Problem, that is a apparent expansion of a liquid is a, suppose the gamma 1 in a particular vessel A. So apparent is equal to gamma of actual liquid minus of 3 times of alpha 1, and the gamma of second vessel में apparent जो आएगा that is gamma liquid minus 3 of alpha 2, and we know the alpha 2 means it is a linear expansion of the vessel B. We want to calculate the alpha of the B and subtract them. Gamma 1 minus gamma 2, and that is equal to minus 3 alpha 1 plus of 3 alpha 2. So gamma 1 minus gamma 2 plus 3 alpha divided by 3 is alpha of the second means of the B. It is a linear expansion coefficient of the vessel B. So the correct option is a fourth one. This is a coffee mug which cools from 90 to 70 in a 4.8 minutes, and the room temperature is 20 degree, and applying Newton's laws of cooling. Then according Newton's law of cooling is proportional to the temperature difference, temperature of the body and the surrounding. It means in the first case 90 to 70, it means the total temperature fall is a 20, and the 20 time taken is a 4.8 minute is proportional to the mean temperature, not 90 not 70, it is a 80 minus surrounding is a 20. It further by 10 degree further होने के लिए 10 और कम करने के लिए टेम्परेचर जाएगा 60, and the mean is a 60 plus 70 and by 2 65, and the surrounding is 20. The temperature difference is a 10 and time taken is a t. Now 20 by 48, and it is t by 10 is equal to, it is a 60 by 45. So it is a 4 into 48 by 2 into 3, 16, 2 to 4, so the t equal to 32 means 3.2 minutes because it is 4.8. So the correct option is a third one. And according Newton's laws of cooling, d theta by dt is equal to temperature difference, that is a delta theta, and the proportional constant is a mass into specific heat area and emissivity. So the proportional constant K is equal to E area mass into specific heat, suppose it is S. Then what is the value of the K1 to K2? K1 to K2 is a E1 A1 upon M1 S1, and the E2 A2 upon M2 S2. E1 and E2 is a 1. Area, ratio of the area, A1 to A2. A1 to A2 is a, it is also 1. And the M1 by M2 S1 by S2. So M1 by M2 is a 2. And S1 by S2 is a 1 by 3. So it is 3 by 2. Means the correct option is a. The body cools from 52 degrees centigrade to 36 degrees centigrade in the 10 minutes. So what is the temperature fall? Temperature fall by 16. 16 by 10 is proportional to, what is the temperature of the body? Temperature of the body is a 52 plus 36 का mean ले, it is a 44. So it is a 44 and surrounding is at the 20. 44 minus 20. Suppose the temperature is a, now the 36 to, suppose temperature is theta. So the temperature is a falling is a 36 minus theta, and temperature जो फॉल हुआ है जिसमें थीटा टेम्परेचर फाइनल टेम्परेचर थीटा है, उसके लिए टाइम उतना ही 10 मिनट है. देन इट इज़ प्रोपोर्शनल टू, नाउ वी नो द टेम्परेचर इज अ 36 and theta. Mean of the 36 and theta is a 36 plus theta by 2 minus 20. यदि इनको डिवाइड कर दे तो 16 अपॉन 36 माइनस थीटा इज इक्वल टू 44 माइनस 20 इज अ 24. नीचे एलसीएम 2 ले ले, 40 एंड थीटा माइनस 4, 16 1 एंड 16 3 जा. So theta minus 4 equal to 3 into 36 minus 3 theta. So it is a total 4 theta equal to 36 into 3. It is 108 plus 4. So theta equal to 112 by 4, and that is a 28 degrees centigrade. So the correct option is the first one. In this given problem, the black body emits 10 watt per centimeter square. Then we know the power, emissive power is proportional to T to the power 4 when E equal to 1. It is a perfectly black body. And the sun is also a black body which emit the 10 raised to power 5 watt. So 10 raised to power 5 watt is proportional to temperature of the sun to the power 4. And the 10 watt per centimeter square के लिए टेम्परेचर 427 डिग्री सेंटीग्रेड प्लस 273, that is a 700. So absolute temperature is a 700 to the power 4. So 10 raised to power 4 equal to Ts by 700 to the power 4. So the temperature of the sun is equal to 7000 Kelvin. 7000 Kelvin means third option is correct. In this problem, the given that the slab third means second. In the second situation, conduct double thermal current. Temperature difference same है, करंट सेकंड में डबल है. इट मीन्स रेजिस्टेंस का रेशियो फर्स्ट केस का और सेकंड केस का 2:1 आएगा. Then resistance in the first case is a R1 plus R2, and in the second case is R3, and that must be equal to 2. In this situation both are in the series, so R equal to L by conductivity into area. In the first case R1 is a 2L upon conductivity is 2K into A, plus second में L upon 3Ka, and this one it is 3L upon twice of K, not A, and that is equal to 2. कॉमन ले लें, कॉमन लेते हैं तो ऊपर बचता 1 + 1/3, इट इज़ अ 4/3 अपॉन 3/K0 is equal to 2. So I think K0 is equal to 9/4. So first option is correct. Two spheres of same material है, it means the radii are R and 2R, and the most dominating wavelength is the spectrum is observed to be ratio is 1:2. Then we know the power, emissive power. टेम्परेचर की बात करें तो टेम्परेचर ऑफ द फर्स्ट टू द टेम्परेचर ऑफ द सेकेंड इज इक्वल टू अकॉर्डिंग wind displacement lambda mt is a constant, so T is inversely proportional to lambda m1 to lambda m2. Therefore the ratio of the spectrum is a 1:2, so it is a 2. Therefore T1 by T2 is equal to 2, and the emissive power is proportional to T to the power 4 multiplied by area. So emissive power of the first to second is equal to A1 by A2. A1 by A2 is the radius ratio is a 1:2, so area of 1 to area of 2 is a 1/4. Therefore it is a 1/4 is a ratio of the area, and the ratio of the temperature to the power 4, so it is a 2. 16/4 it is a 4, so the emissive power का ratio 4:1. Second is correct. In this situation copper sphere जो कि पर्टिकुलर 500 केल्विन पर है, 300 केल्विन वाले चैम्बर में रखा है, एंड इलेक्ट्रिसिटी जो कंज्यूम हो रही है दैट पावर इज इक्वल टू 300 वाट. वी नो द पावर इन दिस सिचुएशन इज इक्वल टू एमिसिविटी इंटू एरिया इंटू T to the power 4 and T0 to the power 4. It is temperature of the body and temperature of the surrounding. In the situation 300 watt is a power and the emissivity is a E, and this is a 500 and 300. But in the next situation when the power consumption is more because the half of the surface of the copper is completely black, now the emissivity of the half area is a 1 and the remaining half area is the same, and the temperature same, but the power consumption is just double. So equation second को first से divide करें तो it is 2 equal to 1/2 plus E by 2 divided by E, so it is 2E is equal to 1 plus E by 2. 2 means it is a 2 times, so 3E equal to 1. That's why E equal to 1/3. So emissivity is a 1/3. So first one is correct. In this condition the two situations are given, दोनों में temperature difference same है and the ratio of the heat current find करना है. So temperature difference same है, it means I of A upon I of B is inversely proportional to the thermal resistance, and thermal resistance is LA, or a thermal resistance in the first situation is RA, in the second situation is RB. So thermal current in the A to thermal current in the B is equal to in the second situation, it is a two rods are in the parallel, so it is a L upon Ka. इसका L upon Ka हो जाएगा, इसका L upon twice of K हो जाएगा. Therefore it is a 1.5. It means L by 3 Ka. In the second situation, first situation में आ जाएगा, that is 3 by 2 L by Ka, because it is a L by Ka plus L by 2 Ka. So it is a R1 plus R2 is a 3 by 2. So it is a 2 by 9. So the correct option is a fourth one. It is also a case of the heat transfer. Suppose the junction temperature पूछा है, temperature of the junction पूछा. Suppose this is temperature is theta, current is coming from 80 and 90. So current is proportional to all are the three rods are the same material, same cross section. Then we can say the total current in the 80 minus theta upon R plus 90 minus theta upon R, that is equal to theta minus 40 upon R. So it is a 3 theta equal to 210. That's why theta equal to 70 degrees centigrade. Fourth is correct. 10 minutes to raise the temperature of water from 0 to 100. It means suppose the rate of the heat is R and the R is multiplied by 10 minutes is equal to mass of the water is a M, and the 1 calorie per gram per degree centigrade is a specific heat of the water, and the temperature increasing 100, 0 to 100 means del theta is a 100. Now what is the rate of the heat? According this rate of heat is calorie per minute is a M into 10 M. Now the 55 minute takes to complete into the vapor, so M into L V equal to rate of heat is the same and time taken is a 55. Then put the value of R from equation first, then it is a 10 M or a 550 M equal to LV. So 550 calorie per gram is a latent heat of evaporation. So third is a correct. In this problem, the 2 kilogram of metal at 100 degrees centigrade and the specific heat or a heat capacity is a 0.5 times of the water, and we know the water का heat capacity जो होगा that will be the 1 calorie per gram or a 4.2 joule per gram or 4200 जूल पर किलोग्राम पर डिग्री सेंटीग्रेड. तो इसका मतलब ये जस्ट आधी है, और 1 किलोग्राम वाला वाटर कहाँ पर है 0 डिग्री सेंटीग्रेड पर. सो हीट गिवन इक्वल टू हीट टेकन. Then what is the heat given? Heat given is a 2000 gram into C by 2 into 100 minus theta, and that is equal to 1000 into C into theta minus 0. Then according to this problem, the temperature will be exactly 50 degrees centigrade. So the first option is correct. Identical rods हैं जिनका हर एक का रेजिस्टेंस सपोज हम R ले लें, that is R. Then C junction का temperature पूछा है. Then the equivalent resistance is a 3R and the temperature difference is a 180. So इस वाली resistance पर drop 60 degree. So 20 plus 60, the temperature of the C is a 20 plus 60 means 80 degrees centigrade. 80 plus 60, it is a 140 degree centigrade. at this point, and 80 degree centigrade is a C. 80 और 140 के बीच टोटल 60 का ड्रॉप होगा. 80 प्लस 30 110 ऑफ ईच जंक्शन 110. बट पूछा कहाँ का, जंक्शन सी का पूछा, और सी के लिए हमें पता इट इज़ 80 डिग्री सेंटीग्रेड. सो करेक्ट इज द सेकेंड वन.